Okay, so now that we talked about how to write the formulas, let's talk about how to name them. So if you have a name, you'll be able to write a formula, and if you have a formula, you'll be able to write a name. So we talked about the structure, the formulas. Now we're going to talk about the structure of the naming system. And so it's a lot like the formula. You're going to go name of cation, and then you go name of anion. Okay, and there's going to be a little bit of tricks with the name of the anion, but the cool thing about the cations is it's just the name of the element that it is. And so let's look at an example here, one of my go-to examples, NaCl. So this is table salt. What's Na? Well, we look at our periodic table, it's sodium. And for a cation, it's just the name of the element. Okay? So this is just sodium. Call it the sodium ion, but say sodium in the name. Now the anion, this is a monatomic anion. So again, we're not dealing with the other stuff yet. But we're still just working the edges of the periodic table here. So that was element name, excuse me. So we're going to say something very specific here. So monatomic anion name. We have to do a little trick here. Alright, so monatomic means single atom. Alright, so this is Cl minus. There's only one atom. It's picked up extra electrons and become an anion. That's what we're talking about here. Alright. And so what we do is we change element name ending. Oops. Can't write and think at the same time today, apparently. To ide. So chlorine becomes the anion that is named chloride. Okay? So we change that ending. And this is the exact same process we're going to do the whole time. Now it actually gets a little bit easier when you deal with anions that are polyatomic ions, because that's just the name of the anion. It's the name of the polyatomic ion. So you don't have to change any endings or anything like that. But for monatomic, when it's single atom, and you're just pulling a value off the periodic table, you got to change the ending. So this isn't sodium chlorine. This is an ionic compound named sodium chloride. Alright, so if we have another ionic compound here, let's take a look at it. So again, name of cation, name of anion. That is the foundation of all of this. And name of the cation, we don't have to do anything. You just pull names straight off the periodic table. Name of anion, you got to do some tricks. And so what we can do is write another formula here. How about, I'm going to pick one that has a little bit of trickiness to it. Alright. So you look at your periodic table, you're like, what's Mg? What's Mg? You look around there, where's Mg? Oh, there's Mg. Okay. What's P? So Mg is magnesium. What's P? P is, oh, there it is. Phosphorus. Okay. So, when we name it, well, our cation is just magnesium. Just a magnesium ion. Phosphorus. This is why I chose one that's a little bit tricky. That orus ending, anything with orus or igen, like nitrogen, oxygen, we drop the igen, we drop the orus, so this becomes phosphide. So not phosphoride, but phosphide. So, when we're looking at this anion, this is phosphide. So that's how we change the ending to ide. If we look at oxygen, it becomes oxide. Nitrogen, when it becomes an anion, we change the name to nitride. So the cutoff is a little longer than you might expect, so that's why I'm warning you. But things like fluorine or carbon. Carbon becomes carbide. Fluorine becomes fluoride. So those ene endings. So if you see an I in E, that just gets turned into an IDE very easily. You know, if there's an ic ending or anything like that, or you know, sulfur becomes sulfide. These are really the tricky ones right here. I think I got them all. Am I missing any of the really tricky ones? Look at my periodic table here. No. These are kind of the ones that tend to trip people up just because so much of the ending gets dropped. So just a heads up on that. Be aware. Alright, so there's another thing we can do now. We can fold the idea of this video in with the last one. And so what I've been doing thus far in this video is I've taken a formula and I've given it a name. But we can do the opposite, right? We can go the other direction. We can write a name and then turn that into a formula. So, if we have something like potassium paired with another ion here, like, let's do nitride. Just looking at my periodic table and pulling stuff off here. Alright, and you can do this yourself, you know, if you want to practice. Just look at your periodic table and start pulling elements. Just keep it on the edges till you watch the next couple videos. Alright, so potassium nitride. So, here's what we do. Here's an approach I find works the best anyway. There's probably a couple ways to do this. I just ID what the ions are with their charges. So I go potassium. Potassium. Oh yeah, you can't spell without a K. So there you go. Potassium. Alright. And it's going to be a +1. So I'm just going to write what the ion is. This is a K+. Nitride. Well, that's going to be nitrogen, which is a -1, 2, 3. So we get an N3-. And now we've set ourselves up for what we were doing in the last video. We can just do the little diagonal trick. And so we get K3, and then there's just one N, so we don't write 1, because, you know, there's only so much ink in a pen, so much time in a day. That's it. That's all there is to it. So, another example here. Talked about calcium carbide before. Very reactive. You know, you can light ice on fire with it. That's what I was talking about when I brought it up before. But what's the formula for it, right? What is calcium carbide? So, what do we do? Well, what's the calcium ion? Okay. I don't know. Let me look at my periodic table. It's calcium, so it's going to be a Ca. Alright. And it's going to have a charge, or else it's not an ion. And it's going to have a charge of positive. This is going to be the cation. How do you know it's the cation? Well, it's a metal. Metals are always going to be cations in this class. And then the other, and usually they are just in general, but there's always weird stuff. So it's a metal, and then also it's to the left of the periodic table, and also it's the first thing named in the compound. So there's all these clues. This is going to be the positive charge thing. So you'll never write a negative charge here. You have so many reasons to know not to do that. So just hang on to at least one of them. Alright, and then what is the positive charge going to be? Well, we just look at our periodic table. So it has 2 valence electrons, so it's going to dump those and become a +2 charge. Okay. Carbide. Alright, well that is carbon, which is just C. And it's going to be a negative charge. How do I know it's going to be a negative charge? Well, it ends in "ide." It's the second thing listed. It's a metal and a non-metal, so it's an ionic compound, so it's got to be the anion. It's the non-metal. So it's going to be -1, 2, 3, 4. And then it gets to pretend like it's neon. Alright. So, we got a +2 and a -4. Do the diagonal trick, right? And we get Ca4C2. Are we done here? Take a second look at that. Does that look like a finished product? Well, we have 2 times 2 and 2, which means we have 2 and 1. So that diagonal trick gave us a common denominator of 2. We got to knock that out. So we go from 4, 2 to 2, 1. So I divided both of these by 2 to get 4 into a 2, 2 into a 1. Okay, and now we've got a full formula. So we can go both ways with this. We go formula to name, or using the tricks from the last video, we go name to formula. And we just go in the order. You know, the name is going to tell us the order to write our ions. If you don't remember that cation's first, anion second, well, that's not the end of the world, because the name's literally going to just tell you to do that anyway. So you just follow along. Or if you have the formula, just follow along and write the name. Name the cation, which happens to be the first thing shown, and then you name the anion, which is the last thing shown. So the whole system is built on itself to kind of actually help you out a little bit. As long as you know how to use the periodic table and find those charges. So next we're going to talk about the transition metals finally. We are going to deal with the middle. We're going to attack the meat of the sandwich, alright? So we're going to talk about how we handle this, but first I'll explain all the difficulties. So there's so many more difficulties than you even know right now probably. And we're going to explain that, and then when you feel thoroughly hopeless, I will show you that it actually isn't that big of a deal. So just hang in there on that one.